some of the stuff is pretty sexy, glitzy stuff these days too, the dinosaur work especially. And these can be high-paying gigs for the illustrator. I like this Godzilla anatomy piece. Botanical, so here's some contemporary botanical illustration. So the herbarium here on campus used to have a couple of botanical illustrators. No longer, it's all freelance work. But this is kind of the typical sort of work that a botanical illustrator would do to illustrate a species and to publish the genera for a plant or a group of plants. So lots of detail work, and again, lots of black and white work, lots of pen and ink work. So the computer hasn't really gotten into this world too much because the details are so many and so minuscule that to do that digitally takes you longer than putting pen to paper. I wouldn't have the patience to do a piece like that. I'm not interested in doing a piece like that, but some people dig it. This is Jerry Hodge. Jerry Hodge studied at Johns Hopkins. Jerry passed away a few years ago, but I show him because he was my mentor in graduate school. He's the fellow who started the medical and biological illustration program here at Michigan. He came to Michigan in, I think, 1954, started the program 10 years later in 1964, and was the director for a long time. Excellent, excellent pen and ink artist. He also liked to do a lot of ophthalmological illustration. So work over at the eye hospital. This is a fungus, retina of the eye. So things from simple to very complex, of course, just runs the gamut. Towards the end of his career, he started painting more in this trompe-l'oeil style. This was a big painting that he had in his house that people would think, oh, it's like a letterbox, but no, it's a painting. So he actually got on the circuit doing these trompe-l'oeil type paintings. I'm a colleague of his that was a medical illustrator from Hopkins who ended up going on to medical school. So it's not unusual to see some of these illustrators that are going through medical illustration programs go on to dental school or medical school or vice versa because you're getting the training and you're getting close. But John Cody, after he retired, he is now known as the Audubon of Moths and does these big, huge watercolors and has a couple of galleries that represent him. But goes around the world collecting moths and illustrating moths, which is pretty cool. So some more, the digital botanical work looks a lot more like this. So some veterinary work. Here's a spread from Geographic. So something like this was definitely a very long process. Here's some, I lifted these from our own museum. So these are illustrations that support some of the research that's being done at the Natural History Museum here on campus. Some of the specialty over there are these light whales called durodons. So there's still an exhibit preparator over there. So working in museums and preparing exhibits is another aspect of science illustration. And we still do have one exhibit preparator who is a science illustrator. Here he is, it's John Klausmeyer, so he actually designs and installs the exhibits, but also does the illustration work too. I've had students who work out at the botanical gardens here in town, doing didactic displays and label systems. There's some students working on mold making over at the museum. Some outdoor displays at the gardens. There's some reconstructions. Dinosaurs, cool stuff. So there are a few big companies in the country that do museum preps, either doing the big murals or the models in those. So certainly those self-select people who have the scientific interest in the background. Mostly it's about having the vocabulary. If you can muster the vocabulary and hold a conversation with a content expert, and you've got the visual skills, things can progress along. If you don't have the vocabulary, it's certainly a much more difficult road to hoe. These are some field drawings. I take students out into the field to do field research. Actually, we're leaving after this to go up north with my science illustration class this semester to go do some forest drawings up by Camp Michigan this weekend in the cold rain. Great. Here's some medical illustration, contemporary traditional technique stuff. So that's pretty typical of what you would see in a medical textbook these days. Surgical procedures, so good knowledge of graphics and graphic design and layout. So these are pretty traditional illustration techniques. Nothing too fancy, a little bit of digital. But certainly to get this access point, they're not going to let anybody into the OR, so you've got to have the more advanced training to get into the operating room and spend the time learning the vocabulary, being able to collaborate with the surgeons. This is a pretty typical North American early student piece in medical illustration programs, and it's because Max Bradel had his first students do this exact exercise 100 years ago, and we're still kind of doing that same gig with graduate students these days. Students that go to, so this is one of my former students, we would go over to the anatomy lab and spend 6 hours a week outside of doing the dissection work, but just drawing from cadavers. And that's a pretty typical view of what a medical illustrator in context looks like. A drawing table and drawing tablet, reference books. Certainly patient ed and advertising has been around a long time. So certainly y'all are familiar with the fact that the pharmaceutical industry generates a lot of income. So advertising for them is a niche, and it has been for a long while. Patient education is certainly an area of specialty, so working with public health folks and medical educators to build websites, to build brochures, to build posters, that all exists. So stuff that has multiple purposes, online, in print, back and forth. So that's a pretty typical type of a portfolio of student these days that are interested in medical illustration. So here's a digital version of a cat dissection, so you kind of saw the stylistic changes there. That's a vector-based illustration, so it can be scaled from a little postage stamp up to a billboard if we needed to. I have a couple examples here, if I can get them to run over, of this is kind of transitioning us into the future of using digital data, of collecting motion markers, the visible human data set. I think you probably all have heard about before, where they did very detailed, high resolution CT scans of a couple of bodies from the tip of their head to the bottoms of their feet, and that data set is available for free. And folks have been downloading that data and reconstructing it with digital 3D tools for quite some time. And that's definitely an important part of contemporary work. This is some of Brad Smith's work. Brad is also on the faculty here. So he uses MR data of embryos and uses some specialty software that he's helped develop to tag and build markers to do developmental sequences. So again, for real specific educational purposes. And he can go in and highlight specific systems in embryology. So that's all high resolution MR data. And there's what some of the surface rendering looks like, so some pretty powerful computing. Here's another medical legal case. So the one before was a little bit more complicated than that one. Medical prosthetics is also a gig for medical sculptors. Again, not all of these folks are trained medical illustrators per se. They're sculptors that like to work with patients. So using silicone rubber and glass eyes. So here's a patient who lost her eye, probably to cancer. So having a practice where you meet with the patient and take a mold of her face and build a prosthetic that fits into that and gives huge difference for somebody like this that is constantly bombarded with stares and out in public it's hard for patients like this. And to go from that to this where she can be outside and not experience life with all of the gawking makes a huge difference. So it's obviously a non-functional prosthesis, it's purely an aesthetic prosthesis. So this eye will move and that eye will always stay fixed because it's just a glass eye and a piece of silicone rubber. This certainly has a lot of potential in 3D computer rendering. So this is the traditional process. So here this is a plaster mold taken off of a patient who lost their ear. And you would take a mold of their opposite ear and then physically sculpt using clay the ear that you need to replace and then cast it in silicone. And certainly now you can use digital tools and 3D printers and take a 3D scan of the opposite ear, flip it on the computer, and print it out. And again, that just gets stuck on their head with some medical adhesive. And actually, these prosthetic ears are functional because they do help amplify the sound for folks. So here's another one of Brad's animations. So certainly, liking to work with data sets and 3D animation is an aspect of a lot of folks' lives these days. It's not something that I've personally done. Not something I've been that interested in, but there are lots of folks who are. And we're definitely seeing a bit of a schism between the engineering type folks who like to do the 3D modeling and the rendering that are doing the work and collaborating with illustrators and collaborating with content experts without necessarily having the graduate training. So if we look briefly into the future, using this data set is definitely something that's going to continue to happen. So as we get better at this cross-sectional data and sharing that data is going to be continually used and refined for visual rendering. The use of 3D software to build these virtual worlds and virtual models is certainly a big part of it. So here's that human visible data set rendered out by one person. With the data. Anyone been to Body World before? So this is a plastinated German guy worked out this system of dehydrating specimens and embedding them with silicone rubber. It's a process that a lot of anatomy labs use across the country. And he has this big traveling exhibit of all kinds of people and dogs and horses all preserved using the silicone process. Kind of a controversial exhibit actually, but some people think it's great, some people hate it. These subcellular renderings is definitely a huge part of what's going down. Looking at subcellular processes, viral processes, just as we've been watching the Ebola stuff, we've been seeing 3D models of Ebola viruses on TV and animations of how those viruses are transmitted or moved across space. So different 3D modeling exercises for sure. So these are individuals often, but sometimes they're small production groups that are working in small companies that specialize in this kind of work. So even though the hospitals aren't necessarily hiring and maintaining a department like they used to, folks are coming together and working on their own. Just like I formed Michigan Science Art, we're not under the same roof, but we work together on projects. So, lots of images, maybe you have some questions. We can go back and look at things. Yes, ma'am?
Could you talk about some of the differences between science illustration and biomedical visualization?
Sure. The visualization programs, if you're thinking about, they've been interchangeable up until quite recently. So it was a way of thinking about these data sets and how you can use the digital data instead of having to put pen to paper or pencil to paper and illustrate something, to draw something out of your imagination or use observational skills. It's actually much more of a kind of an engineering process of sorts of being able to take actual data and manipulate it. So that's the basic difference. And we see this overlap, that it is a highly visual thing, and the good visualizations are completed by folks who have the good visual skills. But it's not necessarily always that case. I mean, sometimes it's engineering firms or the scientists running out of their lab that are running the software or doing something similar. So the word doesn't necessarily have to overlap with an illustrator per se. Does that answer it for you?
Absolutely. So would you liken biomedical visualization to more data representation?
I think so. I think that's a fair assessment. And the program at the University of Toronto has kind of taken on that emphasis. So their graduate program is much more about handling those data sets now than it is sitting down and doing a hip bone in carbon dust. Yeah. Other questions? Yes, go ahead.
You talked a little bit about the difference in how people are hired. Like, there used to be illustration teams
Right.
at hospitals and museums.
Yeah.
So, for people that would go into this,
Yeah.
how would you get a job? Right?
Then or now?
Now.
Now, it's all about the portfolio. So, you know, it's chicken and egg. So if you want to illustrate dinosaurs, you just don't show up at the paleontologist's office and say, hey, my name's Joe, I'd like to draw, you know, can I draw a dinosaur with
You
you?
need to get the vocabulary first.
You need to get the vocabulary and actually draw some, and be able to go to the paleontologist and say, hey, are you doing some new work? And here's some of my old work, and maybe we could work together. And you know, if you like what I've done, maybe we can do some more together. So it's definitely one of those things that you've got to build the portfolio to get the foot in the door, to be able to expand and build together with someone. And a lot of times, this culture clash, I mean, I've literally had clients who contacted me and said, oh, you know, do you know anybody who can, you know, illustrate a turtle? And I'm like, oh, yeah, I could illustrate a turtle. Well, I looked at your stuff and I saw, you know, you did birds and snakes, but I didn't see any turtles. It's like, well, no, a turtle's really not that different than a bird or a snake. You know, it's kind of the same sort of a thing. And, you know, but they didn't see the turtle. So they think you don't know anything about turtles. And, you know, you'll fight those kinds of things. And certainly for some things it is important that, you know, if you're specialized in doing heart surgery, that's a different sort of thing than doing orthopedic surgery. And the heart surgeons will be happy that they don't have to train you. You know, one of the things I disliked about doing the human medicine gig is these guys are just so bloody busy that, you know, you could never have a conversation with them. And, you know, I like to be able to sit down with somebody or have an email conversation or a phone conversation. And so like when I illustrated the toucans, you know, be able just to shoot the shit with the ornithologist who's like, hey, wow, cool, you were, you know, up in the forest canopy in Colombia today, what was it like? And be able to talk about it, which is, you know, a fun part of the gig. You know, if it was just like, hey, draw this toucan. Go ahead.
Do you have a rough idea of how many people are able to do this as a full-time career, or is it mostly part-time?
Certainly there are hundreds of people in the country that make a full-time gig off of this. You know, certainly not as many as graphic design. And you know, it's kind of like truck driving. You know, if you want to drive a little bit, you know, you can say you're a truck driver and I drive once a week for, you know, a couple hours a day. Or if I want to make a ton of money, I'm going to drive to the limit of my capacity and drive. So, you know, certainly there's guys out there who are working, you know, 80, 90, 100-hour weeks. And there's some people who have other stuff going on and, you know, take on a job every now and then. And so I don't think there's any easy answer to that. It was easier when we had a lot of staff positions in the country, but as museum budgets have tightened, NSF budgets have tightened, NIH budgets have tightened, you know, those folks have gotten pushed out into the freelance world. Go ahead, Troy.
Are there any like bigger companies, or like what are the bigger companies that hire like staff? National Geographic, do they have staff? Or-
Geographic doesn't really have a staff of illustrators. There's very few big companies that have a staff of illustrators because a place like Geographic wants to be able to have visual diversity in their work. So if they had, you know, me on board as an illustrator, it's like 4 issues later, it would be like, I'm bored of that guy. So they need to have the flexibility and the fluidity to change it up. That said, you know, I've got a good number of students who work for a little custom publisher up in Plymouth, and you know, they've got 4 full-time illustrators that are working, and their gig is basically to do lab manuals for high school and college undergraduate courses around the country. So they're doing basically vector art, all that black and white stuff that can go on the Xerox machines. Other questions? No, go ahead.
Do you think that there should be a movement towards sort of restructuring scientific illustration as a sort of more full-time career? Because it is so often used in education. Do you think there
Yeah.
should be a push for sort of I don't know, feasible full-time careers for more people?
Oh, I think it's definitely a feasible full-time career, and I definitely think that there's value in people studying it as a field of study. Because if you can take the time to sit down and focus and think about how the science overlaps with audience and how you can best understand your audience, that's not something you necessarily get to very intuitively. So learning some business practices, some technical practices, but learning to understand audience and that collaborative skill certainly has a role in education. I'd love to see museums start to hire lots of people, but it's going to take a change in funding structure. Yeah, it's going to take until we see more money going into the NSF and NIH and core science research sorts of stuff. There's still a demand, they're still publishing just as many books, and y'all know if you've been buying textbooks are expensive. And it's not that the illustrators are getting rich off of them, the publishers are making the bulk of the money, but they're publishing. And there is a problem, one of the big issues these days is outsourcing. There's big groups in India and Czechoslovakia and China that are doing this kind of work, and it's not too difficult for folks to get online and say, hey, I need some kidney illustrations, and they can get them for pennies on the dollar. So being able to have the interpersonal skills to be able to work with someone custom and collaboratively is what makes a studio, I think, more successful than not. So learning the culture differences, being able to cross the bridge, that left brain, right brain stuff it's for real. Go ahead.
One of the most interesting stories that I heard while I was working here in the Life Sciences Institute was from a scientist who was working with an animator.
Uh-huh.
He was asking the animator to animate a subcellular process in yeast cell, which he was researching.
Yeah.
And the animator kept coming up with all these different questions that he never considered. And I thought that was a very nice feeding back and feeding forward of information that the scientists didn't really thought of asking, but could also could be pursued scientifically.
Mm-hmm.
Do you have any experience like that where your work feeds into?
Oh, for sure. I mean, in that animal encyclopedia, we had the flexibility to do some conceptual type illustration. So being able to push the concept of it's this deep sea feeding behavior, we don't really understand what goes on, nobody's ever seen it. Can we hypothesize about what it looks like and go back and forth? And certainly I've had clients go, I never really thought about it like that. And it's like, well, is that possible? Could it happen? And it's definitely a collaboration back and forth. So a fresh eye on stuff is often helpful for all of us, but especially for folks who You know, if you're familiar with lab culture and you're familiar with folks working in the sciences, you know, the way you get grants and the way you become successful is you specialize, and you specialize by guarding a little itty bitty piece of turf, and you live, eat, breathe that little yeast cell. And, you know, it's hard to get a fresh perspective when you're this close to it. And having somebody else come in from the outside is like, whoa, dude, what's that yeast cell doing, man? It's like, okay, really? Oh, maybe. Yeah. But it, you know, it takes it takes the willingness of that scientist to be able to take the time to have the conversation. And those are the best people I've liked to work with. You know, the folks that are just like treating you like a visual secretary, you know, it's like, no, I want it blue, make it blue. Those aren't fun. You know, you're just a stupid artist. You know?
I was just gonna ask, like, where you see medical illustrations going in terms of like as microscopic like techniques get better and the resolution gets higher.
Yeah.
Do you see photography taking over then in that sense, or do you still think that there's a lot of conceptual parts
I
that?
think there'll still be a lot of conceptual things, and I think the more moving parts that we see to the complexity of these illustrations and diagrams, the more editing is going to need to happen. So having someone who understands audiences and visual fields and compositions and layouts are going to be useful to have in the conversation. So I don't think it's any new concept. It's like, you know, when the camera came out, it said, oh, you know, no one's ever going to paint a landscape again, or, you know, do a portrait again, or a million other things. And, you know, we still see and understand the value of that editing process. Yeah, go ahead.
Yeah, kind of similar to the futuristic idea. You briefly mentioned 3D printing.
Yeah.
What direction do you see that taking the science illustration?
Well, for the illustrators, you know, I think teaching models will be part of what's going on. You know, I think the really exciting part of the 3D printing that's going on are the cellular prints that they're doing for replacement organs and, you know, actually functioning pieces. And I'm not seeing that necessarily involves the illustrator as much. But certainly the 3D printing for making models and being able to do the non-functioning prostheses, there's certainly visual folks that are involved in that. And you know, I think the big debate that goes on in the educational field is, do you actually need to have a graduate degree or not? You know, does the degree do anything or not? And the degree certainly gives you the experience. So back to the education thing, yeah, the training is certainly super helpful and puts you closer. But ultimately, no one's looking for your piece of paper that says you've got, you know, a degree. They're going to be looking at your track record, and they're going to be looking at your portfolio to be able to say, yeah, you've got the chops, you do the kind of stuff that I need. So the portfolio always wins. Go ahead.
So this is sort of a reflection on what you're saying, and I was wondering if you could respond to it. So you're talking about how someone had been making illustrations of dinosaurs because he liked them, not because he had necessarily the information about it.
Yeah.
And there's been this ongoing, people believe the illustration that they saw first because they liked it.
Yeah.
So I was thinking about this, and something that I've been looking at recently is how the scientific community and the general public interact, because there's a lot of information that doesn't transfer over.
Right.
So have you found, so I was wondering if you had basically any insight into like how the illustration world and how the public interact through science through illustration.
Yeah, well, I think it's a big missing part to the puzzle. And it's, you know, I think something I didn't show here that I think is really important is climate science. So, you know, climate scientists have done a really horrible job in communicating what they know. The oil industry has exploited that fact and put a lot of money into that to be able to continue with misinformation and disinformation. there's not been the money or the willingness to push back against that and do a really well-done educational component towards climate science. So, you know, the idea of communicating science, that the public is different than the ivory tower, duh. And, you know, scientists going to their annual conferences and talking to each other with the same vocabulary about the same stuff, you know, that ain't gonna cut it. And in something as important as climate, they really need to do a much more concerted effort to be able to bridge that gap. And visual folks are definitely part of that. So, you know, graphic designers and illustrators, and, you know, it doesn't necessarily need to be science illustrators per se, but that visual component and that audience component is really critical. Does that answer your question?
Yeah.
In a different way? Yeah, you know, it's different for a medical device company, you know, somebody who's developing a new prosthetic knee for knee replacements, which is huge money. You know, there's hundreds of thousands of prosthetic knees replaced every year. They come up with a new knee, they need to promote that. They need to get the information out to the doctors. They're financially incentivized to make that as glitzy and understandable and approachable as possible, because they've got a product to sell. And the climate scientists and others, you know, that are in more core science, they don't have that same kind of motivation. So there's a disconnect there between ivory tower and general public. And certainly there's a huge amount of room for visual folks to be working effectively. But how do you make a living? How do you get the funding? How do you know, get the rubber to hit the road? It's a harder question. Other questions?